In today's video, we will be going over the law of sines used to solve for various sides and angles of triangles and to identify what triangles satisfy a given set of conditions. For our first problem, we have been tasked with writing the law of sines for the indicated triangle. The law of sines is as follows. The sine of the angle x over the side length x will be equal to the sine of the angle y over the side length y, and that is also equal to the sine of the angle z over the side length z. For our next problem, we need to solve for the unknown values in the triangles by using the law of sines. For our first problem, they have given us a side length of x, the side length of y, and the angle value for the angle x. Using these values, we can solve for the angle y with the law of sines. We plug in the sine of the angle x, which is given as 115 degrees, divided by the side length x, which is given as 49, and this will be equal to the sine of the angle y, which is our unknown, divided by the side length y of 16. Solving for this problem, we must first make sure that our calculator is in degree mode. Once that is done, we can take the sine of 115 degrees, divide that value by 49, the side length x, multiply that by the side length y of 16, and take the inverse sine of that value in order to determine the angle y. Based on our calculations, the angle y is equal to 17.21 degrees. Next, we can solve for the angle z by noting that the total angle measure of a triangle is 180 degrees. So we can state that 180 degrees minus angle x of 115 degrees minus angle y of 17.21 degrees will give us our value for the angle z. We plug this into our calculator. 180 minus 115 minus 17.21, and we find that our angle measure z is going to be equal to 47.79 degrees. We can go ahead and fill in the values that we have determined. Angle y was equal to 17.21 degrees. Angle z was equal to 47.79 degrees. Finally, we can solve for the side length z by once again using the law of sines. We know that once again the sine of angle x, 115 degrees, over the side length x, 49, must be equal to the sine of angle z, which we found earlier as 47.79 degrees, divided by the side length z, which is our unknown. Solving this in our calculator is done by taking the sine of 115 degrees, dividing by the side length of 49. We still do not know the side length z, and so by multiplying both sides by z and then dividing both sides by the value we have just determined, we can determine what the side length z is, and so we take the sine of 47.79 divided by our previously determined value, and that is our side length z. Z is equal to 40.05. We can go ahead and plug that in for our unknown, 40.05. For our next problem, we are first given the side length of x and the angle measures for both y and z. We can first solve for the angle x by again noting that the total angle measure in a triangle must be equal to 180 degrees. And so we take 180 degrees, subtract the angle y of 42 degrees, and subtract the angle z of 75 degrees. And so we get our angle x. Plugging this into our calculator, 180 minus 42 minus 75. We find that our angle measure x is 63 degrees. We can go ahead and plug that in. Next, we can set up the law of sines for this triangle by noting that the sine of angle x, 63 degrees, over the side length x, 22, must be equal to the sine of angle y, 42 degrees, divided by the unknown side length y, equal to the sine of angle z, 75 degrees, divided by the unknown side length, z. Solving for y, we take the sine of 63 degrees divided by 22. We then take the sine of 42 degrees and divide it by our value that we determined. And so the side length y is going to be equal to 16.52. Solving for side length z, we repeat the same process. So the sine of 63 divided by 22. And we take the sine of 75 and divide that by our determined value. And so we get the side length z will be equal to 23.85. We can then go ahead and plug these into our unknown positions. Side length y, 16.52. Side length z, 23.85. For our next set of problems, we have been asked to solve for the triangles that satisfy the given conditions using the law of sines. The first step is to set up the law of sines for the values which we are given. So we can say that the sine of the angle x, 30 degrees, divided by the side length x given as 6 must be equal to the sine of the unknown angle y divided by the given side length of 7 must be equal to the sine of the unknown angle z divided by the unknown side length z. We can then go ahead and draw a picture of the values that we are given. By first solving for the angle y using our calculator once again, you can find that y, the angle, may take on the value of 35.7 degrees. However, you may also find that the value for y, when you take the inverse sine of the sine of 30 divided by x multiplied by 7, you may find that y can also take on the value of 144.3 degrees. Given both of these values, we can use the total angle of a triangle being equal to 180 degrees in order to determine that the angle z, given that y is 35.7, must be equal to 114.3 degrees. And in the case that y is equal to 144.3 degrees, z must be equal to 5.69 degrees. We should then go ahead and draw in both of these possibilities onto our picture. And finally, solving for both of our possible side lengths of z, we can use the law of sines by plugging in the angle of 114.3 degrees for our angle z. We find that the side length in this case will be equal to 10.9. And for the case that z is equal to 5.69 degrees, the side length z would be equal to 1.19. And as we can see, both of these values make sense if we give each of them a label. Z1 being equal to 10.9 was in the case that y was 35.7 degrees. So if this is 35.7 degrees, the side length is still 7 for y, but now our side length for z, where this is our angle z, will be this much longer length of 10.9. In the case that z was only 5.69 degrees, or this smaller angle right here, our length of z is much shorter at only 1.19. We now proceed on to our next problem, where we once again start by writing out the law of sines for the values which are given. We are given that the angle of x is 40 degrees, divided by the side length x of 22, equal to the sine of the unknown angle y over the known length of y, 12, equal to the sine of the unknown angle z divided by the unknown side length z. We can then go ahead and draw a picture of the triangle that we are given thus far. Solving for the angle y, once again, we find two possibilities. The possibility that the angle y is equal to 20.5 degrees, or the angle y may be equal to 159.4 degrees. However, in the case that the angle y was 159.4 degrees, this would imply that the angle z is equal to negative 19 degrees, which does not make sense, and so we can ignore this possibility. In the case that the angle y was 20.5 degrees, angle z, once again using the total angle of a triangle being equal to 180 degrees, angle z can be found as 119.5 degrees. Given these two angles and the law of sines, we can find the side length of z to be equal to 29.8. And so we can go ahead and draw this into our picture. As we can see in this problem, had the angle of y been the original value of 159.4 degrees, our triangle would have looked similar to this smaller triangle in the previous problem. However, because our side length x was much longer than our side length y, if angle z had been negative 19 degrees, our triangle would have looked something like this, because the side length x would have to proceed in this direction as it was longer than our side length y. That concludes this video on solving for various sides and angles of triangles using the law of sines.